While loops are used when you don't know how many times you need to run it. We start with, we're going to initialize a variable, and this, you have to initialize the variable that you're going to be using in the loop itself. So we must initialize that. We have a goal. You can see that that's a limit. And then we have this variable converge. So let's just see what happens. So here's a while loop. You start with while end. If we run it, you can see that, or maybe you can't, but it's an endless loop. So you're going to do this a lot with while loops. Going to hit pause and then quit debugging. All right. Now, what we're going to do is we want to run this loop as long as the converge value is less than our goal. So our goal is 2.5. Our converge value will change, and it must change. It has to change or you'll be in an endless loop. So within the loop, you must change the control variable. And the way we're going to change it is we're going to use a variable count, and count equals count plus 1. So we get into the loop initially, and we hit this count and we change it. So if we run this, you can see we ran it, it worked. It ran 7 times. Our goal was 2.5 and our converge value was 2.593. So how this worked is there's a logic value, and a logic value is either a 0 or a 1. 0 is false, 1 is true. So if we look at this, and if we run it, you can see that the logic variable works. The variable is equal to converge minus goal. So if this is true, then it will return a 1. If it's not true, it returns a 0. And this is used up here, and it tells, it controls when the loop is complete or when you kick out of the loop. Now, the minimum lines you can have within a loop is 1, but they're usually not very helpful. So if I take this out, take that out, and if I change this to count, if I change this to count, and I change this to count plus 1, count equals count plus 1. So I'm changing the control variable, which in this case, which I just changed to count. So if I run this, you'll see what happens is the count is 3 and the goal is 2.5. So it took 3 runs for it to reach, get beyond 2.5. And if we look, well, we'll look later. So the trouble is that isn't very interesting. So you usually use the count to alter another variable, which is the one you're interested in. And that's what we did. So we'll go back to converge. And let's run it again and make sure it's running. Oh, we need converge. Hey, notice I just went into an endless loop when I didn't do that. So now, the way we're changing converge is we start off with converge equals 0. We come in here. The old converge is 0 plus, and then the new converge is the old converge plus 1 over count. So the first time it does it, it will be 1. And the second time, when count is 2, this will be 1/2. Count is 3, it's a third. So let's look at how this works. And I don't think I was clear about this earlier. And what we'll do is we'll create a vector of the counts. So let's run this, and we create a vector of the counts. And there it is. Run it again. We have a count vector, and it's 1, 2, 3, 4, 5, 6, 7, just what you'd expect. Now, if we have a converge vector, so the converge vector is what we'd expect. And it came up to the 7th, and that didn't meet. Well, I'll show you in a second. I suppose I should say, I think I showed you this before, but just to be clear, these vectors are created one element at a time. So the first time it runs through, count vector is a single element, and the converge vector is a single element. Then we come down to 2 elements in both, 3 elements in both, and so on. So we end up with the final 7-element vector of both. And now the logic variable will calculate, logic vector will create, and if we run this, we end up with 3 final vectors. Oh, let's suppress that echo. Run it again. Oh, I didn't mean to do that. I meant to do this. So here's what's happening. The count vector we know, the converge vector, you'll see that it's true for the first 6 runs, and in the 7th run, this is no longer less than 2.5, so the logic is 0. Last thing we'll do is we'll output the results. So as I said before, here is the first value we'll output, which is goal, second value, which is the converge, and the last one is the count. And let's run that. And for a goal of 2.5, you can read it. Notice I made this large so we could be precise on what the converge value finally was. Okay, thank you.